In this video, I'm going to illustrate two examples of how you can use truth tables to test propositional arguments for validity. So these examples are number 5 and 11 in your book in section 2, and then you have to do several others for the homework. So basically, when we test arguments for validity, we're looking at whether there is what kind of logical connection there is between the propositional statements. So to begin, you're just going to do the truth table the way you would for a single statement, and then what's going to differ is at the end when we look at it for validity. So the first thing I'm going to do is do my truth table, and we'll look at this first one. It only has two propositions in it, so we just need 4 rows in our truth table. We have K and L, and for K I'll do true, true, false, false, and then for L we have true, false, true, false. Put a line there, so I made a truth table down the side. And now what we're going to do is we're going to do the truth table for each of these statements. These are your premises, and K horseshoe L is your conclusion. So right now we just want to do it the way we would have done it in 6.3 for single statements. So make sure that you're looking at the main logical operators and using those to determine these. So in this first statement, the biconditional is your main operator. So the first thing I'm going to do is negate L. So it's false, true, false, true. I'm just negating these. And now, if you remember, or if you're looking, the biconditional is true when both sides have the same truth value. So essentially when both are true or both are false. So we have true, false is false. True, true is true. False, false is true. And false, true is false. So now what I'm going to do is circle this. This is the main operator column. Now here, the negation is the main operator. Now remember, this statement is not equivalent to just attaching the not to each of these letters here. So you have to do what's inside the parentheses first and then negate everything inside the parentheses. So the first thing I'll do is negate the K. So I get false, false, true, true. And now I'm going to do the conjunction, and a conjunction is only true when both sides are true. So if we're looking at L and K, we have false, false, and then we have true and true is true, false and true is false. And now when we negate that, we're going to get true, true, false, true. And I'm going to circle that one because that's the main operator column. And now for the conditional, we have true, false, true, true. Remember, the horseshoe is only false when the left is true, the antecedent is true, and the consequent is false. When both are false, it's still true. Okay, so now what we need to do is check this for validity. So if you remember, a valid deductive argument is one in which it's impossible to have true premises and a false conclusion. And when you're doing a truth table, you're laying out all the possible truth values for the premises and conclusion. So if a valid deductive argument cannot have true premises and a false conclusion, we need to look at the row where we have a false conclusion, and we want to check. If we have one false premise, the argument is valid. But if we have true premises and a false conclusion, the argument is invalid. And if you look here, we're looking at the second row now. A little bit not lined up, so I'll circle it there. Here you have true premises and a false conclusion. Therefore, this one is invalid. So remember, if you find what you're looking for, it's invalid. If you don't find what you're looking for, it's valid. And what are you looking for? True premises and a false conclusion. Okay, let's try the second one. We have K, R, and S. And this one, we know when we have 3 propositions, we're going to have 8 rows in our truth table. And I always put a line there just to make it easier to follow. Okay, so we start with 4 true, 4 false, 2 true, 2 false, and then true, false, true, false. Okay, so that's how I did that one. I'm going to put a line there too just to separate that. Okay, so now let's look at our first premise. Remember, we're just going to do these the way we would do any statement. The negation here is your main operator. So we're going to do what's in the parentheses first and then negate it. Okay, so we're doing K triple bar S or K biconditional S, which will be true whenever both sides have the same truth value. Okay, we have true, true is true, true, false is false, true, true is true, true, false is false, false, true is false, false, false is true, false, and true. And now we're going to just negate each of those. So we're going to get false, true, false, true, true, false, true, false. And I'll circle that so that when you go back to take a look, you don't accidentally look at this one. Okay, over here, the horseshoe is the main operator. So we're going to do this side first. We want to do the disjunction and then negate it. We have R wedge K. Remember, the wedge is true when one or the other side is true or both are true. It's only false when both are false. So we have true, 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 false, false. And now we can negate that. False, 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 true, true. I'm going to do that so I can see it. Okay, now we need S, horseshoe, and then we have the right side. So true, horseshoe, false is false. False, horseshoe, false is true. True, false is false. False, false is true. True, false is false. False, false is true. True, true is true. And false, true is true. Okay, so that's our main operator column. I'm going to put a little star there. And now we just need to do the conclusion. So we're going to negate S, which gives us false, true, false, true. False, true, false, true. And now it's R, wedge, and then we did the right side. So true, wedge, false is true. True, wedge, true is true. Both are false, so it's false. Right's true, so it's true. True, true, false, and true. Okay, so now we have this column here. Here we have two possibilities, right? We have to take a look at these two rows here. Now if we look here, we have false, false, and false. So that does not show it to be invalid. That row is fine. But here where we have a false conclusion, we have true premises. So this one is once again invalid. Remember, because it's possible to have a false conclusion with true premises, the argument is invalid.